we are going to start our focus on arithmetic sequences. Arithmetic means that we have a common difference, which means we are adding and subtracting between our terms. So that's the pattern that we're looking for. So we're going to talk about recognizing arithmetic sequences and then how to find the nth term. So writing that a sub n equals and getting a general rule for a sequence that is provided. So first thing is to define the word difference. That's the subtraction of two values. Okay, that's already typed up in your notes for you. An arithmetic sequence, then, is a sequence in which the difference between consecutive terms, so consecutive terms are the ones that are one right after each other, when the difference between them is the same. Okay, so if this is a sub n, this then would be a sub n plus 1. And if I take a sub n plus 1 and I subtract a sub n, that is called my D, or difference. There's a formula box around it that says D equals a sub n plus 1 minus a sub n in your notes. Super, super important. That's how you find your common difference. Okay, and that's how you can check to see if a sequence is or is not arithmetic. So, determine whether it's arithmetic. If it is, find the common difference. So, you want to look and say 2 minus 1 is 1. 4 minus 2 is 2. Is that a common difference? Hopefully you said that 2 is not equal to 1, in which case, no, this is not arithmetic. Okay, so then we can look at 2.5 minus 3. That's going to be negative a half. Then we want to look at 2 minus 2.5. Well, that's negative a half. Just to be sure, let's jump over here. 1 minus 1.5 is negative a half. Are these all common differences? Yes. So yes, this is arithmetic, and our common difference is equal to negative 1/2. If we check this one, negative 8 minus a negative 12 is going to end up being 4. Negative 4 minus a negative 8, 8, not 18, is going to be equal to 4. 4 minus 0 is equal to 4. So yes, this is arithmetic with a difference of 4. The natural log of 2 minus the natural log of 1. We know that subtraction, you could rewrite that, and that's just the natural log of 2. Try these two. The natural log of 4 minus the natural log of 3. We know that subtraction, you could combine these into the natural log of 4/3. Are these numbers the same? No, so this is not arithmetic. Last one, 5.7 minus 5.3 is going to be 0.4. 6.1 minus 5.7 is going to be 0.4. 6.9 minus 6.5 is 0.4. This one's 0.4 also. So yes, this is arithmetic with a difference of 0.4. Okay? Explain why the following sequence is arithmetic. Well, looking at this, 8 minus 3 is 5. 13 minus 8 is 5. 18 minus 13 is 5. It's arithmetic because there is a common difference of 5. Okay, so why does it matter? Well, if we think about this as being n equals 1, 2, 3, 4, and we've talked about thinking about these as inputs and this as an output, this sequence is creating a list of points, the point 1, 3, the point 2, 8, the point 3, 13, and the point 4, 18. If I were to plot those on a graph, (12, 13, 14, 15, 16, 17, 18), okay, and I go over, I don't even know where my 4 was, over 4, up 18, over, what did I even just say, 3, 13, over 2, up 8, and over 1, up 3, I just created a line that has a slope of up 5 over 1. So this is the line y equals 5x. Now, if this were to continue all the way back, we got to find the y-intercept. It's going to be 5x minus 2. So an arithmetic sequence can help us define a linear function. If you think about that, repeated addition turns into multiplication, which is where we get that slope, and then we just need to adjust for what our starting value is equal to. Alright, so what is the formula to find the nth term, so a general term, of an arithmetic sequence? There's going to be a lot of stuff happening here. I want you to try to follow along the best that you can. Okay? You have a formula box over to the side. In that formula box, I would like for you to write a sub n equals d times n plus c. We're going to say this is our common difference, which you have a formula to find that. Okay? This is our index, right? Whatever term we're talking about. This is our general term. So we've got to talk about finding this constant. How do we know what our y-intercept would have been on our graph? Or how do we know what we're starting with? Well, our constant is going to be equal to the value of our first term, the value of our first term minus our difference. Now, sometimes you're not given the first term, but you can still find your c value. It'll be whatever term you are given minus d times that n value. Now you'll notice this formula is just this one switched around, right? Subtract the d times n. That's how you could solve for c if you needed it. Now, this formula over here looks very similar to a y value, in output being equal to some slope times our input plus our y-intercept. And they are very much related to one another. Okay? So, recursively, you got another box. Go ahead and in this recursive box write a sub n plus 1 is going to be equal to a sub n plus d. This one, all you need to remember is that you must know a previous term. Right? Just like all recursive things, you have to know a previous term in order to find the next term in a recursive sequence. Okay? And then underneath recursive, you've got some room to write, and you have yet another formula box. In that formula box, I want you to go ahead and write a sub n equals ax plus n minus x times d. So, labeling these things, d is still our common difference. Okay? Now, this is where things get interesting. So, if we think about the fact that we're talking about a linear here, we have another way of writing a linear function, and that's y minus y1 equals our slope times x minus x1. Well, our slope we know is just like our common difference. We know that our y value is like our general term. Well, this was the term that I got when I put in n, which means this x turns into an n. Okay? This then can be viewed as minus. We're going to use a sub 1 for right now. Well, this term is what happened when I put in my first x value. Well, in this case, my first x value would have been 1. Solving this then, I get a sub n equals, if I add this to the other side, a sub 1 plus, I'm just going to switch this around a little bit, n minus 1 times d. That's this same formula over here, except instead of 1, maybe I didn't know my first term. I knew some term. Maybe I knew that a sub 4, right, was equal to something. Well, then this can just turn into an x for whatever term I happen to know and whatever n value. So this is our other formula. Now, when do you use these formulas? Well, it depends on what you're given. But I've got everything labeled over here, these 3 formula boxes that you can reference. Keep in mind that this is how you find your C values. Okay, that's going to be important. We're going to do some practice. Find the nth term. So that means find the a sub n of a sub 1 equal to 15 and a sub k equal to a plus 4. Well, in this case, we're just going to use our original formula of a sub n equals dn plus c. Because we know our common difference, it's right here, I'm adding 4 every time. So a sub n equals 4 times n. We know how to find c. C is equal to a sub 1 minus d. That's in our formulas. So c equals a sub 1 minus our difference. 15 minus 4 is 11. Okay? So when you're given that initial value, the a sub 1, and you know your difference, all you gotta do is use that first formula. It's going to be the easiest way to go. Alright, find the first 5 terms of the arithmetic sequence. Here, were we given our original a sub 1? No. So we're going to have to do a little bit of detective work, and I'm going to say we need to use our third formula. It's going to be the most helpful. We can't define this recursively because we don't know our first term. We can't define it using our nice a sub n equals dn plus c because we don't know our first term. So we're going to have to use the messy one. The messy one says a sub n equals a sub x plus n minus x times d. Well, I've got a sub 4 is 16, so I'm going to go ahead and write 16. And then a sub n, that means my n value was 4. I know a10 is 46, so 46 plus, I know my x value is 10. This allows me to find my common difference. Solving this, subtracting 46 is negative 30 equals negative 6d. That means that d is equal to 5. Putting this back into a general equation then, a sub n is going to be equal to, I'm going to say 16 plus n minus 4 times 5. So I just plug stuff in. You could also, if you wanted to, instead of using the 16 and the 4, you could have used the 46 and the 10. Either one will get you there. So now if I need to find a sub 1, I just plug in 1 to this formula, 2 to this formula, 3, 4, and 5. Go ahead and pause your video, see if you can get a sub 1 through 5. If you notice, these have a common difference of 5, and a sub 4 is equal to 16. Alright, find the formula for the nth term of the arithmetic sequence. Well, in both of these, we have our a sub 1. That's the best situation we can be in. So we just need a sub n equals d times n plus c. Well, our difference is 4. So 4n. To find c, I take my a sub 1 term and subtract 4. So that's going to be 11. Done with that one. This next one, we're going to use what we did in the last one a little bit. So I'm going to say 16 equals negative 4 plus 5 minus 1 times d. So 16 and 5 correspond. Negative 4 and 1 correspond. We're running out of time, so we're going to go quick. If you solve this for d, d is equal to 5. So I know that a sub n equals 5d, because I'm using this formula still, and I need to find c. Well, c is going to be negative 4 minus the difference, which is 5, so this will be minus 9. Both of these can also be written using the other formula with the a sub x and minus x times d. So your x value was 1, oops, in both of these, and you can find it that way. Alright, there's one for you to try on your own. Go ahead and do that, and then I'll post the answer, and you can ask questions tomorrow if you did not get the same answer I did. If you didn't get 131, ask tomorrow.